So hi everyone, and welcome to this Hacking the S&P 500 Data webinar. This is in the context of the UBS Quant Hackathon 2020. Welcome everyone. So in this webinar we wanted to cover the first few basic steps to join the platform, to get acquainted with it, and then to get started working on this first competition. This competition is part of the first round of the hackathon, which allows participants to access the second round. So that's a qualification round. Without further ado, let's get started. Before we begin, we will use a few notebooks for this webinar. They will be published under the public notebooks section on your dashboard. We will also have a Q&A session after the presentation. However, as everyone cannot talk at the same time, please type in your questions during the presentation, and then we will reply at the end during the Q&A session. We will also endeavor to reply to most questions. However, we might not be able to do that, so we encourage you to start a new thread on the forum. The forum has been very active over the past few days, so we encourage you to continue that momentum. So this is what we are going to cover today in the webinar. First, we'll just get an overview of the platform and how to use it and how to navigate through it, and then we'll move on to the coding environment. We'll see that there are a couple of constraints when you use the platform, and that's very much by design, and then from there we will move on to how do we retrieve data for this competition, and then how we use data features function in order to basically subset and have a nice visuals around data. Lastly, we will talk about how we create a payout for stock selection, and this is mostly going to be about giving you some hints and some ideas about how to structure this, but we won't be doing any code during that section. So let's get started with the introduction. Most participants should be familiar now with this view. This is the dashboard. From the dashboard you can pretty much navigate through all tools that we have put together so that you can do your research. So let me just jump to that. This is my dashboard at the moment. Obviously you could access the webinar through this panel. You can also access directly to the competition rules, the UBS competition rules, through this event box here on the right with UBS. One of the key parts of the dashboard is this notebook section where you can directly go through the tutorials. You see that there is the Quant Hackathon 2020 first steps for the outperforming the S&P 500, and also in R. So you have both languages, Python and R, that you can access. On the left-hand side is all the menu. So the menu is really key in when you want to navigate. You can find all competitions here. So if you click on Alphien, you end up here, and here you can see all competitions. So for our purpose here, you have two key pages. One is this one, the UBS Quant Hackathon 2020, and this is key because it's going to help you understanding how we are going to select, amongst other things, participants from the first round to the second round. So I encourage you to read all this section here so that you are sure you understand how we are going to distribute points. So over 3 weeks we will distribute points at the end of each week depending on your ranking and your submissions, and the teams with the most points at the end of the 3 weeks will get through to the second round. So it's really about getting qualified for that second round that you are playing at the moment. So I encourage you to read this, and obviously here it's the specific page of the S&P 500 competition, and you can see the objectives and everything you need to do in there. There's just a reminder, most of you must have by now read these pages, but I encourage you, if anything is unclear, to read them again. The dashboard is quite key, so pivotal to move around, but you have also many ways to find support. So let's just quickly give an overview of what you can do. We've been quite pleased with the activity on the forum, so people tend to ask questions, and we're quite happy about this, and we are endeavoring to answer them as quickly as possible. Obviously you can reply to other participants' questions if you have the answer, that will emulate the competition and make it more interesting. You have the forum, you have the alpha chat that we are actively using to communicate with participants, and then you have a bunch of documentation tools. So let's go quickly through them from the dashboard. You can obviously access the alpha chat from here directly, or you can start a live support ticket here. You can also here under forum access the forum and start a new thread. And lastly, in the research here you have docs where you can have access to the knowledge base and the wiki. Those are two documentation centers. Knowledge base is just a few articles, whereas the wiki is much more dense, it goes much more into depth. So I encourage you to start with the knowledge base, which gives you a few first steps, and we will see later on. I'm going to open it now, this page, but we'll come back to that. So that's it for the documentation and support on the website, and this leads us to the research and the coding environment. So now that you know where to find support and you have all the information you need in terms of what you need to do during the competition, you can move on to starting some coding. Now we have a few points about the coding platform that we would like to explain, and this is that basically during this competition we are willing to give every participant the same chance of winning or going through the second round. What does it mean? It means that everyone gets the same hardware and software. You all get 4 gigs of RAM, you all get 2 CPUs, you have the same data in the same libraries. So there is no one that is favored by better hardware or better data quality or better library. Everyone has the same. And why do we do that? It's because we want the winner to be the best strategy or the best model, and not the best hardware or the best at getting data. This is really key for us. We favor equality, and we want just people that are really thinking hard and working through their model to win and to go through. So that's one of our key pillar and our philosophy here. Obviously, we give the choice to you to do that on Python or on R, which you can basically pick depending on how familiar you are with it or how comfortable you are with it. So that's totally discretionary to you, and that will be independent from on our side when we are assessing the strategies. We also wanted to give you some advice, given the constraints that we just described around hardware, notably. And if you have 4 gigs of RAM and only 2 CPUs, you cannot use brute force all the time. So you need to be smart. You need to think of a strategy to get through the data without using too much. And our advice to do that is to work with a small sample of data. Basically, you always work with a small subset of what is available. You don't work with a full data set. You mature your idea, you develop, you test, you try, and once you find something that has a bit of interest, then you start scaling up. You start to add more dimensions. So if you start working with 20 stocks, that's plenty. You can test, you can try. It's going to be much more quicker to compute strategies, for example, or to test your model, and then you will get a much better understanding into what the model is doing. And then once you do what you want it to do, and the target is well understood, and you know that your model is doing exactly what you want it to do, then you can scale up. You can, if you have a payout that is using 20 stocks, then it should be just a matter of changing one variable so that instead of using 20 stocks, it uses 50 stocks. But the computation is just going to be longer, but it's not going to change the meaning of the strategy. And that's really key, because if it's the same meaning, then you're saving much time when you're just fine-tuning and doing trial and error on a small sample. So this is really a key message we wanted to get through, and I'll show you later in the coding environment that you can also check if your code is using too much resources, and if there is something that you can maybe optimize there. Last point that I wanted to raise in the coding environment is that we endeavor to document all functions. So you'll see that there are a lot of functions sometimes, and to know how to use them, we have a key tool which is called the QUIB. The QUIB, you can access it from the research panel here, the quantitative library QUIB, and it looks like this. On the left side, basically everything here is a file system. So let me fold everything. This is public, so everything that is under public is a bunch of packages, either in R or in Python. And you can choose if you're not interested in R, or if you're not interested in Python, then you unclick it and you'll see that there is no longer Python. But if you include Python, you see new ones appearing, vice versa. So in this tool, everything that is public, you have a view like this. We'll come back to that, where you can have a wiki page with the documentation, how to use the function, and then you can dig into the code. This is the Python version. You have the R version here, and you can dig directly into the code if you need to. This gives you also quite a good starting point. So rather than starting from scratch, sometimes you just find the function that you like or that is helpful to you. You copy it from the code source here, and then you directly paste it into your IDE and start working from it. So that's quite handy. Obviously, the documentation helps you use the function library here, and that's for the public side of the QUIB. You'll see there is also folders with your team names. Here's my team. So everything that I put under my team, it's empty for me, is going to be shared with my team. So everything that you put there, all functions you put in there, your team members can source them from their coding environment. I will emphasize this a bit later. And lastly, you have a folder. Here's my name, Hervé, and everything that I put in there is totally private to me. So all these functions in here, no one can see them except me. I can still source them in my environment, but they're totally private to me. So if you want to cooperate with your team, just put all functions in a team. Here's my team Alphien, where we have functions that we share amongst the team. We'll come back to QUIB slightly later, but that's a key tool in order to develop your functions. Last point I can show is that whenever you save a function, which is what I've done here, you have revisions, which is quite nice, because all the changes I have made to this particular function are recorded, and so that you remember what you've done and you don't lose any information. So that's quite nice. So this was for the advice and basically the way you can leverage the coding environment. Now I propose that we just jump in to coding and to retrieve data, because this webinar is really around how do we explore and how do we get going on right footing with the S&P competition. And I will jump into the Jupyter Lab here. It's here. So I've prepared a notebook. This one is in Python. So for this section, data retrieval here, we will look at a Python notebook, and then for the next section we'll look at an R notebook, so that we share knowledge around the two languages. So as usual, you should have read how to use the Alphien package, but the first thing to do, so I'm just going to rerun myself here, is to basically import the Alphien data package. I'm importing star because I don't want to type alphien.data all the time, so you can do that to get a shortcut. Once you have uploaded this section of the package, which is Alphien data, all functions in Alphien data are available into your user space. Okay, so if we go back to what we've seen in QUIB, what does it mean? It means that I'm in Python, so I'm only looking at Python. So everything that is in data here, all these Python functions, are now available in my notebook. I can directly call them by their names because I've done import star, and that is what I'm doing here. So one of the functions here is called get tickers S&P 500, and let's check it out. So this is giving me this data frame just below. I'm just getting the head of it. So some tickers, company name, constituent start, constituent end, and industry code and industry name. So let's go through it. Ticker is the standard in finance when you want to have an ID for a stock or a security in general. The security has a ticker. It's standard in the industry. So whenever you want to designate a specific time series, you're going to call it by its ticker. The name is equivalent to the ticker. It's unique. One ticker is one name. Constituent start. This is quite key. It means that basically, as we're dealing with the S&P index, there is an inclusion in the index, and the inclusion in the index starts at that date, basically. So we see that Apple was included. Apple was included here in 1982. It's a pretty long inclusion, but other companies like Advanced Auto Parts, they've only been included in the S&P in 2015. So prior to that date, the stock was existing, but it was not in the S&P. So what does it mean? It means that for this competition, you need to invest in S&P stocks. If the stock is not included in the index, then you cannot invest in it. And so we'll see later that it's important to know at any stage if a stock is inside the S&P 500. Same with the constitution end. So this one is the reverse. Alcoa started to be in the S&P 500 in 1970, but it dropped out in 2016. So that's the same. Doesn't mean that the stock went bankrupt. Maybe it went, maybe it didn't. But what we are sure of with this information is that from 2016 October, end of October, you cannot invest in it anymore. Now we will cover this slightly later in the presentation, but it doesn't impede Alcoa from coming back into the S&P slightly at a later date. So we'll cover that later. And then we have the industry code and industry names. Here you can see these numbers. They look quite big, and I don't see much pattern in them, but we'll see below that we can make sense of them. This is just the letter representation of that code. So we'll cover that slightly later. So this is basically what we have. Tickers and company name. So it's on the same row in this text because they're basically the same. Constituent start and constituent ends. Indeed, that's the span during which the stock was within the S&P 500. Obviously, if there is a null here, it means that it never dropped out. Okay, so you can assume, and you have to assume basically, that it's at the end of 2016 the stock is still in the S&P. What do I do next? What do I do next is I extract this ticker column here, and I'm just checking the structure of this table. How many unique tickers do I have? Obviously in Python set is going to retrieve the unique values there, and I see there are 667 unique stocks that are in this table. However, here we go. This table has 679 rows, so there are 12 stocks. That seems to be duplicated. They are duplicates. So why is that the case? Well, it's the case because, as I said before, this stock, for example, dropped out from the index in 2016. But it doesn't mean that it cannot be included at a later date. Now, given the structure of this table, how do we materialize a new inclusion? Well, we have to add a new row with the same ticker. but obviously a different span. So you need to account for this. You need to make sure that you understand that it doesn't mean that there is a mistake and that the ticker has been duplicated. It means that it's been included, excluded, and then included again. So you need to be able to handle this in your payouts. So as I said during my introduction, we encourage you to always work with samples. So here I'm just taking a small subset, only the 50 first stocks, and we're going to jump into basically getting the history of them. So let's have a look at something, but first what I want to do is to just start a new kernel here. We can start a new Python kernel, and what we're going to do is do exactly what we've done here. I'm just going to import the data from there. Here we go, and from here I can call the get history function. I will show you in a minute why I'm doing this. Here I'm interested in this get history. So we just by the name we know that it's going to give you some history data, but we'll see a bit more into details how we can know what it's doing. Here I'm just going to retrieve data for some tickers, and I want just to time it so that basically we know how much time it takes to retrieve the full data set of tickers. So here I'm just saying give me all the tickers that are available in the get ticker function, this one, and give me the whole history over all these fields: open, high, low, close, volume, and then what we call BB Live is the adjusted close price. Okay, so I'm just going to let that run, and it's going to time it, and we'll be back to it. In the meantime, here we stopped with the few sample of 50 stocks, and then we want to grab their history. Why did I stop here? Because there is a function called get history data, and first reflex when you don't know how to use a function or what you don't know what it is, you can go to the QUIB. You can look for get history data here, okay, and it's going to list the functions. I have it already open here, and this is the R version, and you have also the Python version here. Okay, but the interesting bit is that when you don't know how to use the function, you just go to the documentation and then you can understand what everything means. For example, here I know that the function is to retrieve a time series from ticker names and fields. Now if I don't know exactly what ticker names means or field means, then I can go and check out the documentation. We're going back to the knowledge base I was referring to before, and here there is a page called cheat sheet for data access, and if you read here on the menu, you'll see that there is an available data type, and actually what is interesting to me is data field. If I go to data field, here we're dealing with securities that are equities. Okay, so that's here, that's the equity. We're not dealing with building blocks. You can check out what building blocks are on the platform, but usually it's future contracts that are rolled. This is not the object here. We are looking at equities, and so for equities, what is it telling me? The field convention is that you can have open price, high price, low price, close price, BB Live, or volume. Okay, and there are a few examples here of how to use that. So I just wanted to show you that documentation is there if you don't understand something. Let's go back to this. So I know how to call it. I know that the fields can be open, high, low, close, volume. So this is a quite handy shortcut to get everything at once, basically in one field. And then BB Live, as we said, is the adjusted close. Here we go. So that's open, high, low, close, volume, and BB Live. That's 6 fields. Okay, 6 fields. So I'm just going to request that, and then get the tail of it. I don't need to retrieve it now because it's already there. But I can see directly that if I show the table, the format is I can see the ticker dot, and then I can see the field. ticker.field, ticker.field, ticker.field. So I know that it's going to be in columns. The dimension is going to be number of tickers times number of fields, basically. And here I have some dates. Here I've displayed the tail, but if I display the head, I can see the beginning of the time series. And that's basically the data set we have at our disposal. Now, if we go back here, I can see that I could retrieve the full history across all tickers. So we said 600 odds tickers, 670 tickers, something like that, in around 24 seconds. Okay, I've done that, and now data here is inside my RAM. Okay, and I still have plenty of RAM. So the full data set is here of stock prices across all the available fields. Let me repeat, the available fields are open, high, low, close, and adjusted close, and volume. So 6 fields across 670-ish stocks, and RAM is still plenty of room. Now I can just kill that. Just a tip here, I can see I have 1, 2, 3 things that are running. If I go in this icon here, I can see all the kernels that are running at the moment. What is a kernel? A kernel is just a Python or R program that is interpreting the language. So I don't need to have this anymore. It was just to show you that you need around 20-25 seconds to retrieve everything, and then from there, once it's in your RAM, then you can obviously do more transformation on that and build strategies. So that will be for the later stage, the mature stage, as I call it. If we kill that, we see that this drops, and look, the RAM gets freed. Okay, so basically the full data set took something like 400 megs. So there is plenty of room with 4 gigs to be able to construct a portfolio. Here, so the data set looks like this. You have understood the structure, ticker.fields, and it goes across. Here I have only 300 stock, but you can do the same for the full data set. So that's really price data. Now we could see above that we have a bit more information on price. We have also industry. So if you want to start doing some grouping, some clustering, or some allocating to stocks depending on if it's a defensive sector or if it's what's called a cyclical sector, then you will need this function get GICS description, and this description is decomposing the industry code that we have given you into what it means. And you'll see that basically the way it works, let me show you. Here the way it works is that you have a top level, like a large sector, for example, energy, and then it goes towards more granularity. Okay, so I'll let you dig into that if you want to extract some value from the industry code in order to cluster or to group stocks. Right. I think just to emphasize, because we're having a few questions about this, about stock prices, the only fields that you have at your disposal are open, high, low, close, volume, and then adjusted close, which we call BB Live. Okay, so that's 6 fields. There is nothing more. So this is the data set concerning the stocks. And you have also some description. So as I said, just sectors. Here, what I'm going to do is just look at the airline industry. Okay, so I'm just looking at the first 50 tickers here from the first table, and then what I'm going to do is to select all airlines from these first 50 tickers and just plot their price. Okay. Here I'm plotting the adjusted close BB Live. I need to run it, that's why I haven't run that cell here, just to show you. But once I get the prices, I should have no problem into just selecting just the airline industry, and then plotting the graph. You can see that here the favored way I use to do some filtering on the data, because I know now that the structure here, the structure is ticker dot field. Here in my filtering, I do use ticker dot the field I want, BB Live, and then I just extract the right field I want, and then data frames. So every price series we return are data frames. So you can select by names. So that's my list of names here, and then plot directly that. This graph here, this confirms what we had in mind. So here in this first 50 tickers, I only have 2 airline companies, and this confirms what we saw from the beginning, is that first of all the time series are not all equal across equities, and we also saw that inclusions are not equal. So we know we have time series, we know they have a different length. Do we understand just from this here what was the shape of the time series? Well, we could see the dates roughly, so 23 to 27, 8, 9, 30. So it looks like it's skipping the weekend, but we can just confirm this down there. So here we can just check the frequency, or the infer the frequency from the data. So here we just take the index of this series and see what basically the most frequent difference between 2 consecutive index is. So that's why I'm just doing one minus the other with a slight shift in the index, and we see that most difference in the data set between the two different rows basically is 1 day, but sometimes it's 3 days. Okay, so that's basically the weekend. So this is what we thought. It's basically working days. The series is returned to us with the working days, so that excludes weekend. And then sometimes you can see that there are bank holiday, because instead of having 3 days, then you have 4 days, and that's a bit more rare. So that looks like it's in line with weekday frequency. So if you want to use Panda's preset frequencies, you can set it to weekdays. Now let's move on so that's about stocks themselves. Let's summarize. You have 670-ish stocks, and you have for each of them 6 fields. Obviously, let's say Netflix was IPO'd only in the middle of the 2010s. Okay, so around 2014, I think. So there is no price data prior to that. So you need to adapt to that. So there will be some series with a lot of NAs. Okay. That needs to be taken into account because here we are just describing the raw data, but when we start to transform them and make some computation on top of them, you need to make sure that your computation is not going to break if some time series contains some NA. So that's stocks, 6 fields by 660 something. Let's move to macro data. So you have some set of what we call macro data, and these are what we could describe as exogenous rather than being the price themselves. They are a series that are meant to describe the states basically of the global economy or regional economy through some proxies. Some of them could be stock indices, other ones could be for example credit in the US. So I'm just going to check what is available. I'm just going to get rid of this because that's not too many. Here we can see you have, for example, this is fixed income. You have the yields in the US. So you have the 210 curves, and you can see you have some commodities and some credit metrics. So that's credit spread is how risky credits in general are in the US. So investment grade means somewhat safer than high yield, which is usually referred as junk bonds. So you have a bunch of macro data here that is telling you something about the state of the global economy or the US economy, and that's up to you to use them to create some signals. As I was saying before, you could use them, for example, typically to select if you're in a bull market regime or in a bear market regime, and depending on that, but maybe you want to allocate to very cyclical stocks that would perform well when the economy goes well, or you want on the contrary to be selecting stocks that are very defensive because you expect the economy to be in worsening shape. So that's quite interesting to see if it's giving you any information. For this time series, it's only the default fields. See, I'm not using any field here. I'm just requesting them by the ticker, and by default the field is close price, and that's just one data point across the time span of the competition. So this you can use also in your payout. So you want to basically create signals on this with this data, but you cannot invest in them. That's the difference we make on the platform between something that you can invest in and something that you're just using to generate a signal. Let's move on to this part, which is basically around what it is that you will need to do in the competition. And as we've seen before, the first ticker table gives you the components of the S&P, but you need to only invest in stocks that are part of the index. Okay, so what it means is that you will need to exclude stocks that are not part of the index as of when you want to invest. I've seen a question go through asking about the composition of the portfolio, the S&P 500 at the beginning of the year. Apologies about this, but this is not what you need to do. You need to do according to the table that we have given you in the tickers function up there, get tickers S&P 500, and that tells you if the stock is within the S&P or not, and you can only invest in stocks that are in the S&P. So this means that it's adding some sort of constraint in terms of how you can select your stocks. What you are sure of is that you want to exclude stocks that are not part of the S&P at the date you are trying to generate your weight. This is something to keep in mind. So given that constraint, here I've just written a function that is taking in some a minimum date, a maximum date, and a ticker list. And what it's doing is it's telling you if it's included in the S&P 500, to signal inclusion in the S&P 500. So if we look into this and use it here, I need obviously to run this cell first, and then just apply it to the tickers that we have selected above, which are the airline tickers. And then you can see it's telling me that in 2015 this was part of the S&P, whilst the other one was not part of the S&P. If we remember correctly from the graph that we've seen above, this time series started much later than this one. And so it's basically a matrix of 0 and 1 that are signaling if a stock is part of the S&P at a certain date. I think that would be useful if you come up with such a matrix to help you filter out. This is the same matrix, but for the full ticker list. Okay, tells you at dates, at every date, if it's in the S&P 500 or not. So you might be willing to start creating such a matrix for you in order to help you filter out the stocks that you don't want to invest in. That's just a suggestion. Now, this is all for just data exploration of the data set. Let me just quickly summarize, because some people I know want to use always more data, always alternative data. This is not the rules of the competition. The rules of the competitions are fairly clear. You have only 6 fields with stock prices, and then you have an extra set of time series, which are called macro time series, and which are 16 of them that you can use to help you generate your signals. So that's all. That's the full picture. So if there are questions about alternative data, or can you integrate your own data, the answer is no, because the rules of the competition would then disqualify the solution that uses them. So at the end of the day, the competition is to go through to the second round, and that would be a pity to spend time creating a strategy and not being able to be qualified because you have used some data that were not allowed by our sponsor. However, just to make things clear, whatever you compute from this raw data, let's call them raw data, so these 6 fields from stock prices, or from these 16 series, whatever you derive directly from them is absolutely encouraged. This is what you should do. You should use this raw data, transform them, create new features to create your stock picking strategy. At the end of the day, the strategy is not, as we have highlighted in the forum, it's not about determining the construction of how you allocate to certain stock versus another one. It's really a stock picking. You need to pick the stock, and you need to pick 50 of them amongst the available index. Okay. Once you have selected the 50 stocks, then every one of them will have only 2% of the portfolio allocated to them. You will see also on the forum that there was a question about, do we take into account the NAV and the drift in the NAV, so the market value of the underlyings, so that basically something that is 2% today is no longer going to be 2% tomorrow because there are market moves. And we've replied to that, so I encourage you to look at the forum answers about this. But long story short, you just have to give them 2% at rebalancing date. When you decide to choose, when you pick your stocks, it's 2%, and then you don't have to worry about what's happening between two rebalancings. Let's move on to the next part, now that we know that the raw data is 6 fields across stocks, and then the 16 macro series. Let's see what we can do to just try and work with them. So let's go to data features, and that was a good I could see a question about this, and indeed you can derive and you can enhance this data set. This is just the raw data set. So obviously your strategy to exist and to know how to pick the stocks, you will have to find some information, or to generate some information, or to transform the raw data into something valuable that is going to help you generate this information. So you have a few ways to do this, but obviously, as we covered before, I encourage you to start with doing this with a very small subsample, and then you will be able to scale up once you have a working code with a small sample. Okay, so let's move to that. As I was saying before, I'm going to switch from the Python notebook to the R notebook now, so that I can show you a nice function that we have, which allows you to manipulate data and basically to subset data in order to apply some features to it. Here we go, we're back here. So I don't need that. I'm going to jump to my R notebook. So you will see we will publish this, but basically the first part is pretty much the same as what we've seen in the Python part, where basically I'm just doing some data retrieval. You will see, well, I have a lot of functions in R. You see data retrieval is exactly the same function name, so whatever, if you use Python on R, it shouldn't be much different from one from another. So even if you're a Python user, I encourage you to read the R versions of notebooks, Sometimes notebooks are published only in R, sometimes they're only published in Python. So I encourage you to read, because that's very similar, and you can read one or the other and get inspired by the two of them. So you see that we can retrieve data the same way in R. So what I'm doing in the lab, the menus are not folding. That's why I have big outputs like this. Let's jump directly to the end. And what I wanted to talk about is this data features. Data features class, basically. So that's an object. And what we are going to do is first, as always, when we don't know how to use a new function, we are just going to go to the QUIB and check it. I have already it open, but you can obviously search it like this here, and then it explains to you what it does. The purpose of this class is to find a way to basically group data and then apply some transformations to them. But that's up to you to use it in the best way possible. The reason why we have put together this function is to be able to do management of resources. As we said, here you have only 4 gigs. It's plenty of RAM to be able to store data, but the best way is to load the data somewhere in an object and then apply transforms to that object so that you don't duplicate too much information. So this is what data features is doing. Now what I'm going to do is get some tickers and then we're going to look only at the metals and mining subcategory. So this is what we do here. Just need to remember that it's in R. In R, where in Python you put a dot, or you put a dollar to access the data frame columns. Now this is where we are using the data feature. So here what I've done is I've extracted only the metals and mining stickers. Here I am passing these stickers to the data feature object as a list, and then I'm passing in a bunch of fields. So remember that here I'm just rather than writing OHLCV, I'm passing each one individually. That's possible too. And then I'm starting my my data feature in 2010. That's just arbitrary, to be fair. So remember before when we were requesting the full prices from the function getHistoryData, something happened, and it was that we got an output that was like this. So this is basically here. If we just check the size of it, this is 2500 by 300 table. So and that's just because I've looked at the 50 first stocks. So that's quite a big table to read. Okay, it's not very practical. It's not very handy. Here it's just the last 5 rows, but it's still quite a lot of information. So it's not exactly practical in order to explore and to be able to group things. So that's why here in R we have this data feature function that will be replicated in Python very soon. And from there you can basically group things together. Here my metals and mining sector is all grouped there. I have all the fields, and what I can do is create the objects. So when I create the feature, basically nothing is really triggered. I just know that I want information about metals and mining around these fields over that period. How do I know that? I can just print what I've created here, and it's telling me that within the data feature I have these stickers and I have these fields, and that the start and end dates are these. you'll see. And date, I have given nothing, so it's giving me basically today's date. But we know that the data set stops before, not a big deal. There is a method called load here. So there is a load method that in R you would need to call here, data features, load here. You can see it, and it's telling you that it's loading the time series in the data feature object. So I'm just going to call that, and basically that's just this is just a warning. So it looks impressive in the notebook because it's red, but a warning in R is just a message. It's just informational. It's not blocking. So this is still doing something. It's loading the data when we call that, and you can see here, please note that the start date has been changed from 2010 to 2010-04, so the first basically trading day of 2010, but the end date has been changed from arbitrary today to the end of the data set, last point of the data set. So that's okay, that's what we wanted. It's only giving me the data that exists. And then what you can do is start building some subsets from that. So here, so that's just because R has very small plots, so that's just about plot sizes. But here, what I'm going to do is use another function called data feature subset, which is going to take this data feature and is going to create a subset. And so it's taking the data feature, and then I'm just saying I just want the close price, because if I start graphing everything on the same plot from what I requested, open, high, low, close, volume over all these tickers, then I'm going to end up having a plot that is absolutely no use. It's going to be cluttered, there's going to be too many series, and it's not going to be readable. So instead of that, I'm saying, okay, just give me a subset of this frame with the close price, and I want to plot it. I want to use this keyword, which is rebase all. Again, when you don't know how to use something, go to the QUIB. Here we're using a plot of a data feature. So if you type in data feature, you can see data features plot. I have it already here, and it's giving you all the keywords you can use. I've used rebase all. Here it's rebase all, and that's set to true. So it's telling me that each time series is going to be set between 0 and 100, so that you can compare easily the time series. So let's do it. Okay, up. I'm using, okay, and that's the graph. So you can see that indeed everything has been scaled from 0 to 100, and that now you can see prices across and patterns. I'm just going to graph it slightly less big so that we can see a bit better. Good. And okay, so that's better. And you can see that now you can compare that everything looks like it's running in motion, in the same sort of motion, but some lines are, rallying, while some others are keeping going down. So that might be interesting to start digging into why, amongst the same sector, metals and mining, some stocks are going down whilst others are going up. So there might be something to look into here. How can you cluster? How can you group the ones that, for example, the blue and the red, and potentially the pink, you want to group them together, whilst the ones that are going down, this bunch here, you probably want to group them together too, and have a different allocation depending on what's happening to the markets. So that's just one subsample I have created, but you can create obviously many more. Have a play with it. Here I'm just using close price with field, but you can see that there are other dimensions in the data feature. You have tickers too, so you could subsample, you can create a data feature object, send every ticker from the ticker universe, and then subsample specific tickers that you want with a subset function here. Have only a list that you have pre-selected, plot them together to see how they go, and then you can use these. Basically, if you look into the data feature, so we call it df or df1. If we call it df1 in R, you can access an object by doing this, and then there is an attribute in R. It's called a slot. That's called pxs, prices. Here we go. Just going to do that, and it's giving me prices basically. So this object contains the prices, the close prices of. Let me just get them in a smaller. All the tickers of this object, and only the close price. So that's a nice way to start grouping things together and just start to do clustering. And then you can potentially apply transforms. Thanks to this data feature, you can apply transforms to only close prices rather than applying, let's say you want to compute a moving average. You might want to compute the moving average for the close price, but you might think it's not a good idea to compute it for the high or the low. So you can select the fields you want to use and start applying some transforms. Obviously, I'm not going to go much more into details here. It's just about giving you a chance to have an idea of how to group, how to subset, and start making transforms, so that you start to understand the differences between stocks and the differences between sectors, and start to get a logical way to select the 50 stocks out of 500 that are available. So I'm just going to stop here for the coding part. Just give it a play and check if it makes sense. Obviously, if you need us to look at functions, or if you have a request, please post on the forum and we'll answer them. Let's go back to our presentation and the very last bit. So now that you see that you can subset and start making sense of stocks, grouping them, clustering them, and having some visualization, you want to then apply some transforms to them. You can apply to the subset that you've just created. You can apply the same transform to all of them efficiently, so that you're not wasting any computing power or memory. And then what you will want to do from this transform is create a payout. And that has proved somewhat tricky so far. Some people have well understood, but other ones are a bit more wondering what the payout should look like. So here I hope that I will alleviate some doubts about that. And very quickly, the payout function, the concept is really that it is your investment algorithm. So in the context of this competition, it means that this is in the payout function that you select 50 stocks out of the investment universe at each rebalancing date. Okay, so at each rebalancing date, you select 50 stocks. They receive 2% allocation each, and all the other ones receive 0. That's one of the requirements. About the rebalancing date, you choose. You can decide to rebalance at fixed frequencies every month, every week, or at a custom frequency. So if your signal triggers once, one time in a week, and then a month later, and then 2 days later, then that's totally discretionary to you. This is what your payout should determine, basically. So this is the output of your payout, a data frame of weights indexed by the rebalancing dates. This is this. So data frame of weights, 2% for the 50 stocks you've selected, 0 on the other ones, indexed by the rebalancing date. So either monthly, weekly, or whatever that is. The input, we only have one input, is that the first argument of your payout function is a data frame of prices. Okay, so that on our side, we are able to basically recreate or replicate the transformations that you do from raw data into the data that allows you to select your stocks. So basically, it's all about replicability. Your strategy is about getting systematic. You want your payout to run in the future. In the future, we will select new stocks based on new prices, and that should keep on working. So what does it mean in concrete terms? Concrete terms, it means that in your payout function, the first argument will be something like this. Okay, all the data you use to compute your payout. As we said, you can have the 6 dimensions or less if you don't need all the 6 fields, but you will have some dimension, some field associated with tickers. So the size of this input matrix is going to be the number of tickers times the number of fields you use. Okay, and then you can apply within the payout. You can apply transforms to all this. Or we'll show you another way in a later webinar to do that more efficiently. But for now, you can start with having such a structure. And then here, obviously, are the dates with prices, all these prices. And then as output, this is what we summarized before. You'll have number of tickers in the portfolio. Okay, so if you have 500 tickers, you will have 500 columns. Even if some tickers drop out, if they have no prices, you just allocate 0 to them, and your payout needs to be able to do that because you don't know in the future if a stock will drop out or if the stock will go bankrupt, or on the contrary, if a stock gets added, we need to be able to grow that matrix just by passing in a new ticker. And then on the left hand side is going to be rebalancing dates. We've said before it's discretionary. You can do fixed rebalancing or non-fixed rebalancing. So that's about the constraints. So basically, to make just a very quick summary, you go from dimension n to k if n is your number of dates here, n, and k is the number of fields, to something that is outputting something of dimension t, which is t rebalancing dates, and a dimension g, which is G is the number of assets in your portfolio. That's it. That's in algorithmic terms what your payout function has to do. So basically, how do you generate this matrix from this matrix? And the logic behind the two, or between the two, sorry, is what your payout function is about. This is where your strategy is taking its meaning. Lastly, I wanted to very quickly give you some hints about how to construct properly a payout function, because we've given you so far the equal weight example, but in an equal weight payout, some of you have correctly noticed that the only information you need is the number of tickers at a certain date. So you don't need more than one date worth of information in order to generate your payout. And you might be willing to look at something a bit more lengthy. So let's say if you want to compute some correlations, or if you want to compute some moving averages, then you will need, if you want to compute the 50-day moving average, you will need 50 days worth of data prior to your allocation in order to make this computation. So this here is the different ways you could do that. So your payout must be able to handle such stuff. So the goal of the payout is to generate this red dot. Basically, the red dot is the allocation, and it can use backwards all the blue dots. Okay, so whenever you generate a weight at some date, you can use backwards information. That's the blue. Now there are different ways to do that. Either a fixed training window like this, where you always look at between two dates and you generate a certain number of weights using only this fixed window, and then you move on when the fixed window is no longer available. Basically, you move on to a new fixed window, and then you follow the same logic. Or you can have a constant rolling window. Basically, if I want to generate my weight here, I only need I only need 5 days prior prices, for example, 1, 2, 3, 4, 5. So each day I look at the 5 prior days in order to get the information I need to generate my weight here. And lastly, you can use an expanding window. So each day you use all the information that was available in the past in order to make your new weight. And that's really the key message here. I encourage you to look at these charts. They are on the wiki. There is a wiki page around how to make payouts. I will encourage you to search in the wiki for payout and to look at this advice we have in order to help you structure the payout correctly. This is key because it never stops. So in the future, when we add more data points in time, then you'll have more weights, and that's really what makes your strategy systematic. So this was just the introduction for this webinar and for this competition for the UBS Hackathon. It's a lot of talk rather than code for this webinar, but please do let us know about interest in hearing more and having more example or more code, and we'll endeavor to organize a new webinar, probably more focused on coding, but we felt that it was necessary or helpful to give you this overview of the competition so that you get started on the right footing. And now, if there are any more questions, please write them in the side panel so that I'll endeavor to answer them. I'll give it 30 seconds and to check how many questions can come in, and I'll take it from there. So there is a question about when a stock is dropped from the index during an investment period, can its value be converted to cash until next allocation? So that's a good question, and the rules are quite strict with respect to this, and you have to be fully invested. That means that at any point in time, your portfolio will have to have 50 stocks. Now, if the stocks drops, your payout should be able to pick out the fact that the stock has dropped from the index, and if it drops from the index, then it's no longer eligible to be in your portfolio. So there should be something in your payout that basically checks this. And then that's one of the reasons why you would have to rebalance. It's because a stock dropped out from the index. So the answer is yes, you need to replace that stock. Looking at another question. Is machine learning algorithm necessary? Can I just use regressions on my core strategy? Well, yeah, you can use regressions, and then what you can do is add some regularization to it if you want, and that's going to qualify for being a machine learning algorithm. Start with as a general rule, and I think I've noted it before here in my presentation, in my advice here. It's always good to start from a small model, but when I say small model, it doesn't mean only in terms of data, but it also means in terms of simplicity. Start with a simple model, so don't restrict yourself into thinking, oh, I need to do a very fancy advanced machine learning model or deep learning with 50 layers to do something that works. No. You start with simple. Start with simple. Make it work. Make it go through. Check the results, and then you can start improving it. You can start working at the margin, fine-tuning it, adding complexity. But if you start with a large and very ambitious model, there is a high chance that it's never gonna reach the point where it's working, and that you can basically fine-tune it. So the logical steps to reach that point is really to start simple. Start with a small model, a very simple machine learning algorithm or very simple regression algorithm, and then from there you can try and add more complexity. By the way, you can have regressions that are computed by gradient descent, and that would qualify as being a machine learning algorithm, because the machine is learning the parameters of the regression. So don't feel that you cannot use a regression. This is perfectly valid. Yeah, so there is a question about shall we consider the first day of each calendar year for index inclusion, and the answer is no. You should consider the actual dates at which stocks were in the index. So please disregard this information. That's no longer valid. It's null and void, and you need to use the composition of the S&P as is given by the ticker function that we've seen. There's a question about BB Live, and really simply BB Live is stock adjusted for dividend split and other discontinuities that can provoke the prices to jump higher or lower. This is just an adjustment. This is very there is nothing mysterious about it. It's the standard way you adjust for dividend payment or splits. I encourage you, if you want to have more detail about how stock prices are adjusted, to go on your favorite web browser and look for how to adjust stock prices. There are many articles about this, and it's very standard. What it means, though, is that when you do adjustments, obviously the level of the series is no longer relevant. However, what is relevant is the first difference, so the one day change between the level. So that's where the information lies in the adjustment and in adjusted prices. How can you access statistic calculated by port backtest? Again, all the statistics that we are displaying are standard ones. So the formula is available across the internet in your favorite information source. However, as I said before, you have the QUIB, which is listing all the functions that we use. And if you can use the function, it means that it's in the QUIB and that you can look at the source code. So I encourage you to go and check the source code. When testing the algorithm in the unseen data, do we assume there won't be new stocks being included in the S&P? Actually, that's not an assumption that you should make, because if your payout is structured correctly, whether we feed in a data frame with n tickers or a data frame with n plus 1 tickers, your payout should be able to cope. That's the, let's say, the beauty of a payout function, is that it's scalable. It scales with the input that you give in. So whatever the input, and that's back to my first remark, start with a small sample, and then scaling up should only be a matter of changing either the size of the data frame or a parameter in your payout. It should scale just parametrically. So that's really what's important. The key message here about the payout function is that if a stock gets included, or if a stock gets permanently excluded, you're included, actually, because excluded you will still keep it, but included, your payout should still function. So that's a very good test, basically, for your payout. Start with, I don't know, 20 stock. See if your payout runs, if you can get the back test, if you can if you can see if your strategy runs. And then you add in a few stocks. So you go from 20 to 25 stocks and you run exactly the same code. If it breaks, it means that your code is not generic enough. And one day in the future, your strategy that you thought was working then has a new parameter, a new ticker, and then it breaks down. So it's not viable, it's not systematic. And that's a very good use case where you can test. For the interest of time, I think I'm going to close it here. It's been now an hour and 15 minutes. Please do show us your interest on the forum to follow up with your questions. Please give us some feedback. Also, if you want more webinars and what topics you want us to cover, and we'll endeavor to organize that for you. Again, thanks everyone for participating, and happy coding.